Thank you, Robin, and thanks everybody to be here and to invite Axens to be able to discuss a bit broadly about transportation fuel. So I will try as well as ABSL not to be too Axens focused, and then on the discussion you can also ask broad questions. So to make it simple, there are different feedstock. We have been discussing it since yesterday. In the middle there is a plant. Axens is the licensor, so we are technology provider, same as what ABSL was presenting. And then there are different products that comes out of the plant. I insist on this point. It's not only today talking about fuels or ethanol or SAF. There are also some byproducts that are really important to consider as part of the business case. So all those technologies, I will break the wall, are more expensive than the fossil one. This has to be well known by each of us here. After, in the long term, we hope that this can compete with the actual price of fossil fuels. So I will not go into detail of each and every technology that Axens has, but on the renewable part, we have, let's say, split it in 3 different groups. One is the vegetable oil that is more or less known by the industry already, because there are already some capacities of biodiesel or biokerosene known as SAF. This kind of technology are, let's say, mature, quite easily integrable in a refinery or an existing plant. It's 2 hydrotreatments. So this is something mastered by EPC, by refineries, and by licensors. So we have seen in the last 5 to 10 years a lot of those plants being built. We have some references, I think around 9, one with Repsol, if I'm not wrong. So this I've seen, we are seeing a kind of plateau, I would say, in the number of plants that are being built, mainly due to the feedstock, as everybody knows. The feedstock is really limited, and there is also a discussion about first generation or second generation that we have in Europe that is not in the US because they have a different way of counting the carbon intensity. But in Europe today we are mostly seeing second generation feedstock like used cooking oil, animal fats, etc. So again, there is a limited amount of feedstock on those type of feedstock. On the solid biomass, so again, what we call biomass is a residue. So we are not cutting the tree, we are not taking all the biomass, we are just taking the residues of the agricultural and forestry. So it means that we'll take the wood chip and we will take all the grass, for example. If we take the example of sugarcane, you take the sugarcane, you press, you have a juice. If you ferment this juice, then it's considered as first generation. If you take the sticks, the leaves, or whatever remains, then this is considered second generation. And that's what we take in all of those processes. So it's very important. We were discussing about yesterday and today how to educate government and people and the opinion. It's really important here to understand that there is a sustainability aspect associated to those kind of process. So we are here by doing all the life cycle analysis to prove that those processes are sustainable in the long term. So the full value chain, from the harvesting, the fertilizers, how to process it, how to transport it, how to burn it, it's taken into account to show that what is produced is low carbon or renewables. So I will make also the difference between low carbon and renewables, and I think yesterday our colleagues from INET called low carbon hydrogen. It's exactly the same here. If we use something that is biogenic, then we will call it renewable. If we take something that is coming from fossil origin, then we'll call it low carbon. And we can call it low carbon only when we have made the life cycle analysis showing that it's better than the fossil. So for the biofuel, I will talk about it later on. It's a gasification and Fischer-Tropsch, so similar to ABSL. but we choose to go to the liquid fuels, so Fischer-Tropsch behind it to make long hydrocarbon chains. We have a technology that will use wood in a kind of fluid catalyst cracking. So this is based on our historical background at Axens. And we will create some heavy fuels and some aromatics. Everything around ethanol. So today there are different perspectives depending on which place of the world you are. In Europe, again, because we are banning all the first generation ethanol, then alcohol to jet is difficult to materialize projects. While when you go to the US, by making this carbon intensity calculation, they are proving that they can use this corn ethanol to produce sustainable aviation fuel. So this is I would say a stage investment possibility. You buy ethanol from somewhere, Brazil, India, or locally, and then you build a plant to make SAF, and then in a second term, to reach a better sustainability objective, you can make advanced ethanol based on biomass, so it will be like enzymatic conversion. So it's a big word, but it's more or less a beer factory with enzyme, and you ferment, and then it makes advanced ethanol. But again, you cannot compare the first generation ethanol that you ferment a juice that is well known for hundreds of years because we all drink alcohol, right? Or most of us. We are taking the carbon out of the leaves, out of the stick of the plant, so it's much more complex and it takes more capex, let's be honest. But that's how we reach this reduction of greenhouse gas emission. Then we need to go and take those residues that are today valorized or sometimes burned in some countries. Then once you have ethanol, I always say that I think you are the king because you can go anywhere. You can dehydrate and make ethylene, which is the base molecule for plastics. You can go to butadiene. This is a technology we are developing with Michelin. Butadiene is the molecule to go for tires. So in a few years, we are addressing the tire market to make it low carbon as well. And on the bottom, I will talk about it, all the e-fuel scheme with carbon capture, biogenic CO2, etc. So biofuel, the gasification, it's I would say there are lots of companies that have a gasification process. The only, I would say, change here is that we use the high temperature gasifier from ThyssenKrupp that was used in the coal industry, by the way. So the beauty of this process is that we will take the residue of biomass and we'll make it look like coal. So we will dry it, we'll heat it up, torrefy it, we will mill it, and at the end, we can use this torrefied biomass in the gasifier because it looks like coal. And then we create clean syngas because we work at a higher temperature above 1000 degrees. So there is no tar, so all the downstream parts is easy to handle and easy to process. And then Fischer-Tropsch and then upgrading. So why did I talk about this? Because there is another scheme that is using green hydrogen to double the carbon yields. And that's part of the topics of this panel. It's how to use the green hydrogen as well on the transportation fuel. So here, we'll inject green hydrogen from water electrolysis inside the process to double the production of SAF. I make it simple, if I can. We need a ratio of CO and hydrogen at the entrance of Fischer-Tropsch. If we don't have hydrogen, we need to burn CO. Burning CO means water gas shift, so we will create some CO2, even though it's biogenic, it's still CO2. To avoid that, we add up some hydrogen, so we don't need to burn CO. There is less CO2 that is released, and we increase the production rate. I've put some numbers just to give you, again, on the electrolysis part, just to give you rough numbers of what's the capacity that we are looking at today. And with the scenario we've seen this morning with Shell, then you see the capacities we are seeing today. So to reach the ambition of 2050 or 2040 or 2030, then we will need few of this plant, with a small sarcasm. For e-fuels, the technology is a bit different, so we'll use the reverse water gas shift, which is the conversion of CO2 into CO, green hydrogen. We create a syngas, and then again we go to Fischer-Tropsch. So in the scenarios we have seen this morning, and I think most of the scenarios, they look at the e-fuel as a very, I would say, long-term solution. On our side, we are today seeing projects like this in places where the electricity is cheap, so let's say Nordic countries. So those projects today make sense, and you see the capacities that are relatively small as well, but we see those projects that are really concrete and coming up. Do I have more time? Okay, thank you.
So my name's Goldsmith, Sales Director at Coryton. I'll give you a little bit about the background of the company and the technology, but I'm going to spend a bit more time focusing on the adoption, or maybe the lack thereof, of sustainable fuels, looking at some of the problems we have as an industry, and communicating some of the capacity, the scale, the ability we have to decarbonise, particularly transport of passenger car fuels. That will be the premise with which I'll look through this. And then maybe looking at some of the policy amendments that we can bring to aid the adoption of these particular types of technology. So I'll cover this in brief. Coryton started out last 2010. We're an advanced formulator of a variety of different fuels, generally not pump fuels. You won't see us at the forecourt, but we will do everything from certification to emissions fuels, worst case scenario, regional. We're very active in motorsport, from the top tier such as F1 or MotoGP, all the way down to Formula Student. We even support the development in the aviation and marine industries as well. We have a plant in Essex, which is our headquarters, with a production capacity of about 15 million litres, so a drop in the ocean compared to some of the other organisations here, but in terms of advanced fuel formulation, there are very few plants in the world that can make what we do. We began our journey on sustainable fuels in about 2016, and it became our strategic intent from about 2018 onwards. So we are producing at scale. So if a bulk order comes in for a particular type of sustainable fuel, we will be able to supply it. We use an ethanol to gasoline mix, which I think Yvon touched on slightly. So we take second generation bioethanol, and that is oligomerized from dehydrated ethanol all the way through to the array of different hydrocarbons that we need to make the predominantly biogasoline that we use. But despite the fact that we can produce at scale and HVO can be produced at scale, we find ourselves in a situation where current UK policy, certainly for passenger car, is focusing heavily on electrification. We've got capacity to be able to use these fuels now, so why aren't we? They're not being used in anywhere near the volume that they could or should be. Now, sometimes to understand that, it's good to take a step back and start to look at where the problem lies. Now, I know that this is a very simple graphic and people could take these numbers with a pinch of salt, but what it does is articulate some of the issues that we face. Fossil fuels, for all of their adverse effects on the environment, do have one genuine strength. They're energy dense. You don't need a tremendous amount of weight, and you can get a tremendous amount of power. And if we look at the current policy of going toward electrification for passenger car transport, it's aiming at the lithium-ion battery. And whichever way you try to look at the numbers, you're going to have a massive disparity. But yet we have sustainable fuels, which are chemically identical to those of fossil but come from biomass, which generate the same energy density as fossil fuels. But yet they don't make it into policy, or certainly not in passenger car or in the range it should. And then there's another issue. Now, admittedly, yes, this is the mosaic from 2020, the vehicles that are used on the European market, but come the deadline in 2035, when even hybrids are banned, we're still going to have a legacy fleet of vehicles which at the moment will continue to burn predominantly fossil fuel. So we're not going to get or see any of the decarbonisation at the targets the government have set. There's just not going to be a quick enough adoption of electrification, with problems with infrastructure, costs, supply of raw materials for them. I'll make this clear, this is not an anti-EV rant. This is just saying that there's a reality that we have to face. And if we don't start to address this, we're going to continue to emit from what is the biggest emitter, or one of the biggest emitting sectors. And we're not going to be able to change that. So we know what the problems we're facing, but potentially as a collective industry or through policy, we're missing certain tricks, and what are they? Well, I think as an industry, and this is not just at policymakers or governments or whatever else, but as an industry as well, we are chronically lacking in our use of life cycle LCA models. If you take policy at the moment, let's take the EU for example. The original target by 2035 was to have zero emission vehicles. Well, if you look at that on an LCA basis, that's a fallacy. You can't have a zero emission vehicle, certainly not yet. But with the way that policy is actually mandated, it looks solely at the exhaust pipe. Well, in that theory, yes, that's zero emission, but it's not a fair assumption. What you get is sort of an unfair promotion of one technology, and another technology is unduly punished because we're focusing on the technology. And I think, Simon, you said this earlier actually, and I quite like the way you did it. It was, we should be focusing more on performance than we should on technology. We should be looking to set policy that allows for a collective use of technology, hydrogen, sustainable fuels, EV. But yet, policy doesn't use LCA models enough. We as an industry don't do a good enough job of communicating this to the consumer. Yet we work in a business-to-business environment, most of us. But ultimately, the reason that we're doing this, it will filter down to the consumer. If they don't understand this, how do they make an informed decision on what technologies they should or could be using? Now, this is a bit of an essay. This was always going to be a little bit of a therapy session. I do apologise, so I'm going to rant on with this. But if we look solely at policy in the UK, for example, scepticism. There was a piece by the Royal Society of Chemistry, I think it was in the latter half of last year, the Chemistry World magazine, if any of you read it. And it articulated the problem, or certainly the perception, very, very well. Scepticism over the UK's ability to create EV infrastructure fuels consumer plans to stick with ICE. That's a genuine problem. People are sceptical. They don't think there's going to be the infrastructure, the availability of affordable EV vehicles. So then it's reinforcing that same problem we have with legacy vehicles. People are going to hold on to their ICE and they're going to continue to burn fossil fuels. And then the Climate Change Committee in the UK defines complete failures across the board in how the government looks to roll out its policy. It's come up with targets, but it's not said clearly how it's going to get there. It said, well, we're going to go EV, that's it. There's nothing else to back it. That's unfair on EV manufacturers. The OEMs who are going down that route don't have assurance that they're going to have access to the infrastructure needed. You know, and talking about the targets that they have with net zero or whatever else, they're without engagement. The public has not engaged. There's been no clear policy on the adaptation or how they're going to fund the adaptation needed to infrastructure. And they've not declared any cost benefit. Who's going to benefit in society? Where are there going to be problems? This has not come out. And you see either similar problems, you know, elsewhere. The EU, and I have some sympathy for the EU's plight recently. The invasion of, Russia's invasion of the Ukraine creates an energy crisis. It detracts from some of the momentum they were building on green technologies, to use a broad phrase. But then there's infighting within the bloc as well. Germany and Italy essentially holding a gun to the head saying, no, you can't just have full EV. Now, I support the decision, but was the manner in which it was done, was that correct? Probably not. It was a last minute sort of hostage situation. And what it does is it creates a lack of clarity. You know, you then end up in a situation, the IRA was brought up earlier. And so the US have mandated a series of funds. It was aimed predominantly to curtail the progress of China, but it probably did more to upset the EU than it did the Chinese. And you end up in a situation where those funds are being made available, they're not in the EU, and potentially they're at a point of where they're going to lose their technological prowess. Contrast that with Japan, however. They've set themselves more on a performance basis, a target basis. People might claim that Japan is not targeting enough, but what they do is they have a mosaic of different technologies which they're looking at. And we say this from personal experience at Coryton. Our sustainable fuels are finding so much more traction in Japan in terms of research and development than we do with OEMs in the UK and EU, although it is starting to change slightly. So you end up having to go it alone. That's what we have to do now. We've got no policy direction, we've got no assurance, so we have to collaborate. We end up in a situation where we look for like-minded OEMs such as Mazda, where we can demonstrate that the fuels that we make are 100% sustainable, but are drop-in. You can use them with the existing infrastructure. We took an MX-5 and fueled it for 1,000 miles and I think 4 different racetracks across the UK. No infrastructure change. The car was identical to everything that comes off the production line, but the fuel was 100% sustainable. You didn't have to target key markets. If we can't get down to the consumer in one way, can we look at others? Classic cars, motorsport, these are areas which are going to be resistant or just simply cannot electrify. They're going to need to and want to be sustainable, but yet there's no offering. And then ultimately communication. I said this previously with what we're doing on LCA. Sometimes I think we're muddled in how we go about terminology. Everyone's favourite buzzword at the moment is e-fuels. But you can't use that in its entirety. It's a particular subsect of synthetics. We should be using, sustainable fuels. I think, Yvon, you mentioned about renewable fuels and the terms in which you use it. At least you're providing clarity behind it, and that's what we should be trying to do collectively as industry. But then we have to get this out to the people who are actually eventually going to use these fuels, the consumer. If we can't get this out through government or through other means, then we start working with, Top Gear magazine or Harry's Garage, just trying to promote the word, saying these technologies exist. You can use existing infrastructure and start to reduce your carbon footprint now. So what can we do? I realise we're on a bit of a timescale, so I'll keep us moving. But it's a tongue-in-cheek statement saying, acknowledging sustainable fuels exist. Well, yeah, people know they exist, but they never come up in conversation. They never come up in policy. If you take sustainable aviation fuel, for example, that's an excellent model. They use a multitude of different technologies, but it's stated as sustainable aviation fuel. People realise that there are very few other ways to go about it. You have a mosaic of different technologies and providers, all who are either starting to provide sustainable aviation fuel or very close to production. And that happened quickly, and that was with the right policy intent. But why is that same policy intent not put to heavy duty or light duty passenger car? It doesn't have to conflict with EV, it can be complementary to it. The new music is changing slightly. If you read, if you like reading these things, the Transport Committee recently published their latest amendment in March, and the language is completely different. Talking about the emperor's new clothes and putting all eggs in one basket, and I think one particular phrase was, given the existing private car that will remain on the road for some time, drop in replacement fuels from renewable sources could be a no-risk and sensible approach. Never heard that before. That was the first time that had ever come out, and it talks about a significant shift. So we want greater awareness of LCA models, advocate mechanisms by which we can uptake amendments to RTFO or duty relief, and demonstrate that true technological diversity will facilitate greater decarbonisation. So apologies for the therapy session, but thank you very much for your time.
Thank you, first of all, Robin and the rest of the team for having me and to give me the opportunity to share with you what is the vision of Repsol and the contribution to this specific topic of decarbonize, or to be precise, defossilize the transport. The problem is, speak after both of you, is that you have shared most of the messages, so probably I will repeat some of them. But before going through the presentation, just let me make a brief introduction. I think it's well known that in 2015 there was a milestone. It's a game changer with the signing of the first universal and legally binding agreement in the signing in the Paris Agreement. So a few years later, in 2019, Repsol was the first oil and gas company to get the commitment to be a net zero emission company by 2050, establishing some intermediate objectives. And these emissions are not only related with our own operation, what we know about Scope 1 and Scope 2 emission, but also with the product that we provide to the society. So basically, that brings us to the scenario that we need to transform our business model. So from a holistic perspective, we need to think in the whole value chain for producing these renewable fuels, but also change the mindset. I think the era of doing big projects by ourselves has ended. So we need to incorporate partners, we need to create alliance, and to work with them in this new business model. And what is most important for us, and this is a message that our CEO repeats continuously, is that we have to be agnostic to the technology. So only from a technology neutrality position we will be able to achieve this kind of technology, this objective, sorry. So the same way to tell the story that Yvon presented is basically if we look at the whole value chains, what we foresee that in the coming years we will need to incorporate new feedstock to our processes, basically residues, biomass, municipal solid waste, and CO2 among the renewable electricity or the renewable hydrogens. And we will need to face with this new challenge that have been mentioned in the previous conversation. Is the challenge of the availability, is the challenge of access to these new materials, the heterogeneity of this material, the sourcing, the gathering, so on. And in the meanwhile, we need to develop some new technology. We need to close the gap between the technology readiness level of this gasifier, pyrolysis, reverse water gas sieve, and we need to do it because it is necessary to create this intermediate product that can be something analog to what we do with the crude and with the natural gas. This is a product that can be international trade or can be transformed to produce these final fuels. And in this case, it is a challenge, but also it's an opportunity for the industry in Europe that can take advantage of the heavy investment that we have done over the years to update our refinery, because we can replace the potential decline of utilization of some unit with this phase out feedstock, fossil feedstock, and replace them with this intermediate product to finally produce these fuels. Some of them are drop-in fuels, so probably there is not a big challenge to incorporate it in the existing fleet, but others need to be adapted to the new regulation, but also the properties and collaborating with the engine manufacturing. So basically, this can be illustrated in this slide, when what we foresee during the coming years, it will coexist the production of fossil fuels with these new raw materials that I mentioned before, that will be transformed in fossil fuels that can supply to any piece of the mobility, from the light vehicles, heavy vehicle, maritime, aviation, but we will also produce some other products that can help to decarbonize other sectors like the lubricant oil, paraffins, or basic oils. And in Repsol, we got the ambitions to be a reference, not only in Iberia, but also in Europe for producing this renewable product. And we got the ambition to produce by 2030 2 million tons of renewable fuels. That is including the advanced biofuels and synthetic fuels. And as the main producer and the main consumer of hydrogen in Iberia, we also got ambitions of produce the equivalent to 2 gigabytes of renewable hydrogens, and produce the 20% of our polyolefins production is coming from recycle, either from mechanical recycle, but also from chemical recycle. So before to end, I wanted to bring 3 clear examples of the technological neutrality that I mentioned. And the first of all is in the upper left side of the screen. It's an advanced biofuel plant that is located in our refinery of Cartagena in the southeast of Spain, that is currently be commissioning, so it will be operating by the mid of this year, and we will produce 250 kilotons per year of advanced biofuels, transforming lipid soil in HBO or SAF. And with this project, we are avoiding about 900,000 tons of CO2 per year. The second one that is in the bottom side of the slide is what we call Ecoplanta, that is located in the refinery of Tarragona in the northeast of Iberia. And we are transforming 400 kilotons of municipal solid waste. I think in the previous conversation, it's been defined what is the refuse derivative fuel that is coming from this municipal solid waste. and it will be transferred to 20 to 40 kilotons per year of methanol. This project is fully aligned with the European vision, so it's been selected over more than 300 projects to be funded through the Innovation Fund mechanism, and it will be operating by 2025. And the last one that is in the upper right side, this is the synthetic fuel production. So we have done all the preliminary works needed to the construction of a demonstration plant of 50 barrels per day with, in a partnership with Aramco. So I think we are currently waiting for a legal clearance on some aspects. So hopefully in a few weeks or months we will be able to give us or to give more detail about that. But basically in this project we want to demonstrate the whole value chain of transforming the CO2 into final fuels through the reverse gas and Fischer-Tropsch pathway. So as I say, this is a clear example of the different options and the different technologies that we have to produce these renewable fuels, that we are convinced that it's a credible solution to the fossilized the transport, not in a long term, but right away we can start using this technology and contribute to the ambitious goal that we have established. So that's all from my side. Thank you very much.
And a question to all of you, I guess, so you can take it in turns to answer. But what clearly comes across, it's not a single technology pathway, it's multiple pathways, because to get to the sort of volumes you need, you've got availability of feedstock issues, but you've also got other issues to get to the right fuel. So how do you, I think to some extent you've already answered that, but the availability of feedstock and the timeline going forward is something I'd like you to comment on, please. Yeah?
But from my side, I don't see the point in trying to back yourself into a corner. I think if you focus on one particular technology, you limit the scope by which you can decarbonise. Whereas if policy is more pointed with its language, if you said to renewable or sustainable fuels, you take into account all of the different chemistries that Axens and Repsol have spoken about. So you can use biofuels, you can use synthetics. The problem is people get caught into terminology, they take new buzzwords. We're seeing this potentially with the EU at the moment with the transition, with potentially keeping some of the internal combustion engine production. If they focus solely on e-fuel, that's a particular subset. They're not going to have enough capacity by 2035. They change it slightly and it becomes more target-based, so sustainable fuels. You'll have a mosaic of technologies to be able to support it. So I think it's more a case of use the terminology correctly and go on a target basis, and you'll have capacity across multiple different feedstocks, raw materials and technologies. They'll be complementary to each other.
Yeah, I fully agree on that. I think at least from Repsol, our mindset is to be agnostic from the technology. So only if we leave the technologies to compete each other, we will squeeze the potential of that one. But having said that, it is true that that selection is being done by the regulatory frameworks in some cases. So probably what we will see is in the mid-term, the production of advanced biofuels in that second generation that Yvon mentioned, that will be the first to get to the market. And in a future, with the proper development and the reduction of the price, the synthetic fuel will play a role in the market.
Yes. So on my side, I have a small story to tell. We developed this Fischer-Tropsch process back in 2000 to 2010, and for 12 years there was almost no project. Because the economics didn't work, And then there were 2 projects out of 10 years, large capacities based on natural gas. And since COVID, then everything changed. Since 2 years, lots of projects everywhere in the world, people looking at municipal solid waste, people looking at biomass, people looking at CO2, and those projects materialize because there is a premium price on SAF. This is the only reason. Not because we like environment, not because we like greenhouse gas savings emissions, no. The industry works because there is a mandate. Today, if there is, or tomorrow, let's say if there is a mandate in India because they want to have sustainable aviation fuel, then you will have tons of projects in India. But they have decided to go to ethanol. So there are lots of first generation ethanol in India. So I think all this industry in Europe, we have, I would say, a target, ambitions to reduce those greenhouse gas emissions. So we know how to use the vegetable oil, we know how to co-process. So this is creating some quantities, relatively good quantities of products. And then we know that e-fuels will come because in some countries there is electricity available, but we will not do e-fuel in Pakistan tomorrow because the electricity grid is not ready, right? So based on different contexts and different regions of the world, some technology makes sense, some technology will not make sense. And I take the example of gasification. Let's be honest, it's capex intensive. It's really expensive. And we'll not be able to raise this amount of money in some countries, like Africa, for example. So it's a combination of context, price of the technology, availability of feedstock, and of course the regulation.
Thank you. Another question I have, going back to the technology. The technology is agnostic in its own sense, but the regulation is quite often specific. So you have an aviation fuel regulation. There's pending IMO regulations on marine, etc. Then there's automotive. But actually, learnings in e-fuels apply to all three. Can you discuss how can we actually think differently in the way we look at the fuels as a complete technology package?
I'm not sure you have to. Yvon made the point that sustainable aviation fuel is now becoming a key driver. And much as the oil industry of current and of old, multiple products are produced of different technologies. So because you're designing something for sustainable aviation fuel, doesn't mean that that's the only product that comes off that. There will be HVO that comes off that. There will be bio-naphtha that comes off that. Bio-naphtha then goes into other things. You can consider, okay, it's got limitations for gasoline, but you can use it there. You can use it in the chemical industry. One technology is generally not just fixed on one thing, and it can also be adapted. If you take some of the synthetics, biomass or power to liquid, they can be adjusted to produce different streams. They don't just have to produce gasoline. They don't have to just produce SAF. So sometimes you just need one sector to start pulling through technologies, and people can start to adapt them. The technologies generally aren't fixed into one thing. They will produce others, and people will start to benefit off that. The problem is when you mandate one particular technology. So if they say, for a passenger car, you have to use a battery electric vehicle, you've now precluded anything else. Everything else has been taken away. Whereas if you were to say, all vehicles produced post 2035 have to have a greenhouse gas, LCA basis of whatever target. All of a sudden, other technologies come. It doesn't preclude EV, but it starts to bring in sustainable fuels as well. I don't think you have to look at them in isolation. Sometimes one well thought out policy can trigger multiple benefits across other sectors. I don't think it is necessarily in isolation.
Yeah, I think to build on that, I think probably the refuel aviation was the trigger to develop this kind of project, because was the first one to introduce these mandates. Recently, in the RED 3, I think the RF net be counted in the general energy usage and also in the IMO. From my point of view, the technology is not really the big challenge that we have. I think, of course, this technology has to evolve. We need to close the gap between the demonstration plan and the commercial plan, and we need to optimize the production, the integration. But I think that the big challenge that we are facing is with the policy framework, because if we really want to encourage the investment, we need that unstable. But to me, what is more difficult or the big challenge is this unpredictable. So a few weeks ago, we have a clear example when it was supposed to be signing the prohibition of the engineer combustion in Europe. Just a few days before that signing, Germans say, okay, it has to be included the synthetic fuel. And everything has changed. So I can imagine the car manufacturing that has been preparing the strategy to build these electric vehicles, now they have the opportunity to keep doing the same that they have done. So I think the big challenge that we have with this new technology is in the regulation. So we need a stable and predictable regulation, because the technology is there, the willingness of the technologies of the fuel producer is there to build this new solution, but we are playing a game when the rules are changing every day.
So totally agree with what Luc and Alfonso said. I will just focus maybe on the technology part. Just to give another example, those technologies were diesel oriented at the base, because 10 years ago it was diesel market. Mm-hmm. Today it's SAF market. So we need to go back in the technology and try to see what we can do to maximize the SAF yields. So this is first. So there is a technology improvement to be made on this. So it means back to pilot facilities, back to some new catalyst formulation, for example, to maximize again the SAF, because that's what today make a project profitable. And then you have another aspect, which is how to integrate all those blocks, from the reverse water gas shift, the Fischer trap, the upgrading, the electrolysis. And this, I would say, since 1.5 years, there has been lots of progress on how to maximize the carbon retention. So this is something that will be used as a first step. And in the long term, of course, there are ways to improve. For example, the efficiency of the water electrolysis can improve, which will drastically improve the production cost of SAF. And there are also, everybody talk about it, about co-electrolysis. So which means there is a strong integration between the steam we produce in the Fischer traps and the steam that is needed in the co-electrolysis. And this again will bring much better profitability to those SAF production costs.
Thank you. Thank you. I'm told we're running out of time, but I'm just checking, is there one question from the audience? Then you are allowed to ask a question.
Waiting. I guess we're having a tension here between the desire for scale and the desire for flexibility. I mean, these poor policymakers, wanting to create scale, make one choice, and then we all say, oh, but there's all these other options here, and then they create another. So, I mean, there's also, I don't think we can just blame the policymakers. I think it's about, how do we make that choice? Is it going to be a diversified world? Or is it going to be we choose one and we scale and off we go? I mean, how do you look at that?
I prefaced in my presentation I had some sympathy for the EU and what they're facing at the moment. But I think one of the fundamental things that can be done is moving away from a technology focus and going more on a targeted focus. So measuring, greenhouse gas emissions, how targets of decarbonisation. You've seen the technologies that are available from just 2 companies. There's lots of them. The efficient ones, the scalable ones, they'll start to filter to the surface. And then ultimately the consumer will start to get to a point where he makes the decision, does he go EV, does he stick with ICE, whatever it might be. So it's not easy, and I wouldn't advocate that it is, but I just think that we would benefit more as a society, and policymakers would long term have an easier choice if they focus more on target as opposed to technology.
Okay, with that we must move on. So I would like to say a big thank you to all three speakers.